Hello guys! Today we'll start with a question. What would be the result of adding all numbers? In order to answer that, we will need to first specify what numbers we are talking about. The natural numbers, namely
1, 2, 3, 4, 5, 6.
So our question is, what would be the result of adding all natural numbers?
To start, we can do the sum. 1 plus 2 is 3, 3 plus 3 is 6, 4 plus 6 is 10, and so on.
This is an endless procedure that will give us eventually the answer. Indeed, the set of all natural numbers is infinite. This implies that a number of infinite steps would be needed, given that we could just guess the answer. It should be infinity. If that's the case, we would need a proof that what we are saying is correct.
Let's call C the sum we want to compute. C 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. Let's take for C. For C is 4 plus 8 plus 12. Now compute C minus 4C, which is equal to minus 3C. This is 1 minus 2 plus 3 minus 4 plus 5 and so on. We call S that sum. So S is 1 minus 2 plus 3 minus 4 plus 5 minus 6. We now consider 4 times S. So we just take 4 terms equal to S and add them to each other. It will take a little time. This is the last term and that's it. Now, here it comes the tricky part. We take 1 out of the parentheses for the first 3 terms. So we do it for the first term, for the second term, and finally for the third one. In the fourth term, we perform the sum of 1 minus 2, which is minus 1, and put it out. Now we can simplify 1 minus 1. There is a smart way to rearrange all the numbers that appear above in a way such that we have 1 plus a lot of terms which are actually 0. So for example, we have minus 4 plus 5 minus 6, which is exactly 0. All of the terms we wrote are 0. So we have 1 plus 0 plus 0 plus 0 and so on, which is just 1. For S is equals to 1, which implies that S is 1 over 4. But minus 3C is S, so minus 3C is 1 over 4. C is minus 1 over 12.
Serve qualcosa?
This is a surprising result. By adding all natural numbers, we do not get infinite. We actually get minus 1 over 12, which is finite and also negative. Amazing. Of course, the obtained result is wrong. The series diverges, meaning that its values goes to infinite. That's an example of a mathematical fallacy. If we take for granted an assumption which is wrong, we get a contradictory result. Actually, you can prove that potentially the series would lead to any possible result. The question now should be, what wrong assumption did we make? It's not easy to find this out. The point is that it's not always easy to spot these fallacies. And most of the time, they cause the majority of mistakes in math. In our case, by calling C the sum of all numbers, we are adding a number of infinite addends and giving to them a name. But we actually cannot, because this operation of adding makes sense only with a finite number of addends. By making the wrong assumption we pointed out, we prove that the sum of all natural numbers is minus 1 over 12. This value is important both for historical reason and because it's anyway related to that series. The famous Indian mathematician Ramanujan was the first to state this equality in one of his notebooks.
Ramanujan.
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 He then developed a rigorous mathematical way to assign a finite number to divergent series, called Ramanujan summation. In this alternative summation method, minus 1 over 12 is the value assigned to that series. And this is actually used in many areas of physics and math.